Hi, my name is Mike Sinkbile. I'm going to cover question cluster number 3 regarding client-server systems and web-based databases. First question was discussing the advantage of client-server systems being security, and also asking the question, could this also be a disadvantage? So it is an advantage in security using a client-server model because the databases are centralized. So security can be controlled in that central database rather than having to be managed on multiple endpoints for a distributed database. There's lower volume of network traffic to be filtered and controlled and monitored. So those are pluses towards, yes, it is more secure. As far as it being less secure, there is still concern over the data transmission channel, which needs to be secured between the central database and the client that's out remote separated. Also, there's a central point of failure, so that's actually considered a type of security problem. If the database itself is unavailable, that's a security failure. And a centralized, a client-server model database has one point of failure with the database being centralized. So that's actually a good segue into this next question, which was client-server availability is a central point of failure. So what does that mean? Well, the database requires network accessibility, and so it's a centralized design. So the client workstations, when they're trying to connect to the database, they absolutely have to have availability of that connection, that network connection to the central database. That is inherently what centralized client-server databases are. The database is not replicated or partially located on the endpoint. It's all in the server, in the center of the design. So that being said, if the central system has a failure that's even unrelated to the database, say that there was a hardware or software problem that caused that to become unavailable, to lock up, or the central database stopped responding, that would take the entire system down. So this is in contrast to a distributed database where replicas or pieces of the database are located elsewhere. There can be fault tolerance in that type of design. It is more complicated of a design, but a variant of that would be a client-server design where there are multiple server databases in a server farm or a cluster of database servers. The next question was regarding backup systems and asking what scenarios where you would want to have a backup system. Basically, every scenario you always want to have a backup solution for any database system. Some of the areas, the major areas that can be protected with backups would be the communication channels between the clients and servers. You can have redundancy among the channels or failover between the channels so that no one type of link is a point of failure. For example, a simple example would be on a network. If you have a wireless network and a wired network, the wired network may be very fast, but if there's a problem with the wired network, the wireless network is there to take over from the workstations if the wired network fails. So another major area that needs backups would be the physical system backup. So the server itself, where the data is located, needs to have backup components in it. So that can be done with redundancy of its components itself. So RAID, being a redundant array of independent disks, is a way to protect against failure of disk drives. Uninterruptible power supplies would be an example of protecting against power failures. And there's all kinds of levels that can be done for all these individual components that make up a server or a database system. But then the whole system could also be redundant if there's to protect from failures to provide a form of backup. And that can be done with farms of servers or clusters, as I mentioned on the last slide. Data backup would be the ultimate and kind of most common thought of what a backup system is. And that's done a couple of different ways, at least a file-based backup that contains the data that's hardest to replace. That would be the most basic kind of backup. Image-based backups are the arguably better type of backup for data because the entire system can be restored from an image, including the operating system and configuration and software that was installed, rather than a file-based backup which may just contain data or require those other components, operating system and software, to be reinstalled before the files can be restored. Image-based backups typically have faster recovery times for a system because the entire operating system, programs, configuration, and data can be restored from one backup image. Scalability is the ability to handle workload increases. So that's just the definition of it. And how is that done? Well, for file-based or thick clients, that would be done by having basically a higher powered system that can handle more file requests, or more powerful endpoint clients, the clients themselves, or a database design that better supports more users. Typically more tables, separation of data into smaller components will increase performance rather than having one large database with many fields and large amounts of data in it. Switching to a client-server, thin client model also can greatly enhance scalability and capacity. And that's because the workstations that are using the data may have much more efficient requests going back to a much more powerful computer. So to contrast again with the file-based or thick client machines, those machines may open databases for read and write access and lock certain parts of the files, and if the workstations are slower workstations, it'll reduce scalability for other users. But if you have a very powerful server in the center of a client-server design, it will allow you to serve more users more efficiently. And the users also will not lock the database. So that kind of touches on the subject of 1, 2, and 3 tier systems. 1 tier being thick client design, 2 tier when you have a client server design where the database is separated from the users and application technology on the workstation, and then 3 tier design where the workstation still uses client server communication back to an application server, and then the application server in turn talks to the database server in a very high speed connection. So those are all tools to increase scalability. So a back-end processor is when there's a centralized server that is executing requests and processing data as opposed to the workstation. So this would be an example of a client-server design. Specifically, an example of a back-end processor would be for enterprise resource planning or ERP system. That would be, or basically an advanced accounting package or business software package. That's what ERP is. So many ERP packages are client-server in design and have a back-end processor that services requests for the users, the thin client machines. Then a front-end processor, in contrast, would be where the endpoint itself, the thick client as they call it, does the processing. So it opens the files on its own and reads databases, writes database fields, and does all the work, so to speak, itself, does all the processing on the front end. So a file-based ERP system would be an example of that. And a specific example of a file-based ERP you could consider a very tiny one would be QuickBooks, where the program sits on the workstation and the data files are opened by QuickBooks and read and written actively by the endpoint, by the thick client. So internet services, just to walk through my experience in using internet services, the specific question was asking about whether I have experience using Google Docs and other applications like that for file sharing. So indeed I have used Google Docs. I don't use it a lot. For file sharing, I typically use files like or applications like ShareFile, Anchor, or Hightail. Those are applications that are specifically designed for sharing the files, but not so much to manipulate and edit the documents, whereas Google Docs tries to be both the editing environment as well as the sharing environment. So I use those frequently, and then they do have web interfaces and application interfaces so that I can send links to a user. So just kind of walk through a quick example out of those three. Just I'll pick Hightail. If I use Hightail to transmit a file to someone, I'll use my web browser to log into Hightail, and I'll upload a file very similar to the Dropbox function of the Flex solution. So once that file is uploaded, it creates a link that is then sent to a user via an email. So then the user, when they click on that link, gets a secure connection, an HTTPS connection to the Hightail website, and the file is then downloaded from the database structure that Hightail stores. So that's a paid service. I think they may have a free one, but we use Hightail in our business to transmit large files up to a gigabyte in size over the internet. Much larger files than can fit onto email attachments. I also use Evernote, which is also it's a web-based solution, web-based piece of software, which is an advanced database on its back end. It's actually a distributed database too, because I can have a local replica of data from Evernote on my local workstations and mobile devices. It's similar to Google Docs in that it allows you to manipulate and edit documents in the software tool and send links to the documents directly. Dropbox would be another tool that I use frequently. That one would be integrated tightly into the file system of my devices that I use, my laptops, mobile devices, etc. And links can be sent directly from files just on their own without navigating through a website, although the website interface is available. So client-side scripting, I wanted to answer that question. That would be, in client-side scripting, that would be a thick client design where application logic is happening on the workstation. Scripting technologies include JavaScript and VBScript. Those are both languages that execute on the workstation side and present data from websites typically in different fashions. So the code executes within the browser or within the workstation side, and data that is brought over from the server side is presented in different ways due to the client's manipulating of the presentation, not the server side. The server just presents the data and the client formats it. That contrasts with server-side scripting, where technology, the programming technology happens on the server side, not the client side. For example, ASP.NET, Cold Fusion, PHP, these are all scripting technologies that execute on the server side and present content dynamically to the client. Obviously, there should be less demand on the endpoint on the workstation side for this technology. Therefore, this is a very, very popular technology to allow people using all variety of devices, from a phone to a tablet to an old Windows computer to a new Windows computer. When they have server-side scripting available, the work, so to speak, is handled by the server, and this display happens according to what the user has clicked on due to what the server has spit out or transmitted and processed using these scripting technologies. So that is my slideshow, and thank you very much for listening.